Hello, this is Samsa from Draconus, and this is a short introduction to the Draconus Texture Utils, or DTU. DTU is basically a collection of source code for texture processing utilities, slicing textures, generating atlases, processing normal maps and bitmap fonts, reading PSD files, and so on. DTU has numerous examples and it integrates to other Unity third-party libraries such as NGUI, 2D Toolkit, DFGUI, and Futile. Integration is done either directly in DTU or using TexturePacker format. The main purpose of DTU is to help you to streamline your texture art workflow. DTU consists of 4 different kinds of components. The first one is the file format support. Currently this includes Photoshop PSD Reader with more to come. The second one is the heart of DTU. It's an ever-growing list of various texture manipulation operations. For the full list of these, check out the documentation. Third component is the Atlas generator. While the generator might look pretty standard and not even the most efficient one, it has some specialties such as support for multi-layered atlases and bitmap fonts. The fourth component is the examples. These show you how to use DTU, and they can be used as is or as a starting point for your own projects and extensions. Let's now quickly look some of the highlights of the examples included. The example 1 is about Atlas generator. The DTU Atlas generator is based on the source texture, Atlas sources, Atlas definition, and then the resulting Atlas texture and TexturePacker format if that's selected. So here we have this running animation, simple number font, and then these 2 texts and a tile set. So for each of these we have an Atlas source. The animation uses a grid. The number font uses the auto slicing method to cut out all the numbers. The text uses just the raw textures, and then the tile set uses the grid as well. And then in the Atlas definition we have all the sources listed here, and then the Atlas generator parameters. So here is the output Atlas texture, and also if we want to output the TexturePacker definition, you can choose it here. So when I click the generate, I get 2 files, get the Atlas itself, and then the TexturePacker Atlas definition, which could be loaded into a third-party library such as NGUI or Futile. The example 2 is about bitmap fonts. So here we have a simple bitmap font texture made in Photoshop and a font definition file for that. So when I hit generate, I get this Atlas texture and then the BM font definition file. So I have a NGUI font here, which gets updated as well. So here's a simple test scene, which is using the font. Let's make it a bit larger. So now it looks a bit blurry. So I can set this to point sampled instead of being bilinear. And now we can also update the font, add an outline to it. But there's no room for the outline in the letters, so we need to use the expand canvas to add more space. Let's make it even stronger. But now you see that the letters are overlapping each other, so we increase the spacing as well. Now it looks good. So we can also use the smooth outlining here. So that's how the bitmap font stuff works in DTU. Example 4 is about PSD layer extract. This demonstrates a workflow where you can have a single PSD file and output multiple layers from it. So I have created a test scene which just has a cube, which has a material, which is using the self-illumination bumped specular built-in shader. That shader takes 3 different textures. It takes the base texture, which includes the gloss as an alpha channel, then an illumination texture, and a normal map. So I have a texture in Photoshop which contains all the textures we need. This is the diffuse layer, this is the gloss map, and then we have a normal map which is created using 3 different maps. The first map is the light from top down. So this represents the surface as if it was lit from top down, and this is the same for left and right. And also we have this height map. And finally we have also a illumination channel here. So in Unity I have created this DTU layer extract, which uses the PSD file as a source, and it includes 3 kinds of extracts. The first one is a simple multi-channel texture, where we take 2 layers from the PSD file, the diffuse layer and the gloss layer, and here we map how the pixel information from the layer maps to the output of this extract. So for the diffuse we just take the RGB values and output them as RGB values. But for the gloss map we take the RGB values, but we output them into the alpha channel, so this actually takes the average of the RGB values, effectively making them grayscale. For the second extract, this is the normal map. So the mode we have here is the normal map, left and top and height. So this is the most complex one, which first generates the normal map using the left and top lit textures, and then it generates a normal map using the height map and combines it to the normal map generated by the lit textures. So here we can adjust the depth of the height map. And finally we have the illumination texture, which is a simple multi-channel extract with just 1 layer. As with the gloss map, it just takes the grayscale value of the illumination layer and outputs it as an alpha channel. So when I hit the generate button, I get 3 kinds of layers. I get the diffuse and gloss texture. So now you can see that this is the diffuse and this is the gloss baked into the alpha channel. Then I have the illumination as an alpha channel, and then I have the normal map generated from the lit layers and the height map. So now we can play and see this in action. Cool thing about this is that now I can go here and let's say I want to modify the height map and create this circle here. And now when I save it and go back in Unity, I immediately see the effects of the normal map or the height map changes. And I can go and draw something on the diffuse layer as well. And that gets immediately updated here. Example 5 is about generating multi-layered NGUI atlases. NGUI does support multi-layered atlases or complex materials, but the problem is that the built-in NGUI atlas generator doesn't support multiple layers. So we can use DTU to overcome this limitation. So here we have a DTU atlas multilayer which takes some sources and generates atlas using them. These sources are PSD files containing multiple layers, and we output diffuse texture, a normal map and a gloss map, and a TexturePacker definition. And also we modify the actual NGUI atlas. So again, this is an example of direct integration. So if we look at the textures, this is the bump texture. It has a gloss map like that, and then a normal map, and then a base texture. Then we have a hello world text, which is defined only by normal maps and a gray diffuse. And finally we have a normal mapped button. Again we have a normal map like that, and then we have this noisy glossy map and a base texture which also has this subtle noise. So now when I hit generate here, I get these three textures: the diffuse, the gloss map and the normal map. So this is what NGUI would produce for you. But here we have also gloss map and the normal map. And the material is using bumped specular alpha. So I have made a simple example scene which is using those textures. So let's run it. So there's some lights moving around, and these are buttons with colors and tweens, and that's the hello world text there. And I can now demonstrate that if I go here and modify the button, for example, let's put something there. And I save it. And I come back to Unity, you can see that the texture has been changed. Or I can go and change the normal map. Let's invert this normal map. So when we go here, those are actually dents inside the surface and not outside. So that's how you use DTU for multi-layered NGUI atlases. Example 8 is about normal mapped sprites. The source is a simple PSD file with the base texture and then normal map from top and left. What is different in this is that we are using slices here. Each of these slices has a name and the dimensions. So these two are the idle animation, and then we have walk frames. In Unity, I have this multi-layer atlas definition, or custom multi-layer atlas, which takes the PSD file and slices it, and then generates an atlas or multi-layered atlas and produces the diffuse normal map and actually gloss map, which we ignore, and then also the TexturePacker definition, which we also ignore. What makes this custom is that it's also producing this runtime atlas. So when I hit generate, I get the normal map and the base diffuse map. Gloss map is just black, we can ignore that. But then we get this runtime atlas. So this is a Unity scriptable object, and it contains information for all of the frames or all of the slices that were present in the PSD file, and then also some references to the textures. Then I have made this demonstration. Here we have a sprite, and the sprite is using this normal sprite script, which is specific to this example. That example script creates a mesh and is able to reference the different frames found in the atlas. So the sprite is referencing the atlas, the runtime atlas here, and then I can define different frames here. So this supports animations as well. So basically these are just strings, the sprite IDs. It has a rigid body, box collider, and then it has this sprite controller, which is responsible for moving the character. So the script just alternates between the idle and walk animation and handles all the cursor keys and space for jumping and so forth. So when I run this, it looks like this. If you hit N, you can enable and disable the normal map. So you see it makes quite a bit of difference. And that's it. This was just the tip of the iceberg. There's a lot more in store. So get DTU now and start creating your own texture art workflows. Available now in Unity Asset Store. Thanks for watching.